Okay, let's get started with the real physics content. So, all the content in the year will be broken into three major parts: mechanics, electricity and magnetism, and some other stuff in between. So today we're going to start with mechanics. And the first topic in mechanics is kinematics, which is the study of motion. Specifically, we're going to be dealing with 1D kinematics, or one-dimensional kinematics, motion in a straight line. Forward and back, left and right, up and down, motion in a straight line. So let's think about some of the terms we measure when dealing with kinematics problems. So think about maybe if you're taking a trip somewhere and you don't know where you're going, so you punch the address into your GPS, and GPS spits back directions how to get there, and there's going to be certain quantities you want to know when you're planning your trip, some information that's given by your GPS. What's one of the first things you want to know when you're planning a trip? Well, you want to know how long it's going to take, right? So we'll call that time. Alright, so we'll define time as how long something takes to occur, which of course is something you want to know when you're planning a trip. Want to get a little more detail, we'll say it's the duration of an event. Now, every time we define a new term in physics, we're going to talk about what units we use to measure it in, and while there's all sorts of different units we could use to measure time, there are certain units that are standard. If we were in class, I'd ask you if you know what the standard units are, and you probably know what they are. Someone can go right ahead and say it is the second, which we symbolize with a lowercase s. Now, there are plenty of other units you could use: hours, minutes, days, years, eons. They're all very good, but the second is actually well defined. There's an actual definition for exactly how long a second is in terms of other reproducible physical constants. Now, when I write units all by themselves, I put these little brackets around them. It's not exactly standard notation, but it's just to separate it from maybe s is used as a symbol in an equation somewhere. So if I'm just going to manipulate pure units, I'll put these square brackets. It's something that I like to do, is something I suggest you do also. Now, in equations, we're not going to write the word time. We're going to use a symbol, a single letter symbol, to replace time. And if I were to ask you in class, I'm sure to come up with it, it's going to be a lowercase t. So next to this, we'll write lowercase t. And it does have to be lowercase, because capital T actually does stand for something different. And we're very particular about our symbols in physics. And so if I write lowercase t, you write lowercase t. It's not an option. It's not a personal preference. Lowercase t stands for time, because capital T will actually stand for something different. Okay, so as you're planning your trip, what other measurement is important information to know that you might get from your GPS? Yeah, how far it's going to be, right? So we'll call that distance. We'll define distance as how far something moves. But we're going to specify that a little bit more. It's going to be how far something moves, taking into account all the steps along the way. And that makes sense, right? Because if you put an address into your GPS, very often you'll have these different options for different routes. Some of them will be more twists and turns. Some of them will be more direct. It depends on if you want to take tolls or if you want to take the scenic route. But of course, with all those different steps along the way, it'll be a different amount of distance from start to finish. And so that's what we define as distance, taking out all those twists and turns, all the steps along the way, how far something moves. Again, we're going to define standard units, and there's all different units we could use to measure distance, but in the metric system, what do you think the standard's going to be? Right, it's going to be the meter, which we'll write here as lowercase m, and again, we're going to use these square brackets around it to designate the fact this lowercase m stands for meters, as opposed to where lowercase m will stand for something else in equations later on. Now again, in equations, we'll be using a single letter symbol to take the place of distance, and if I ask you, you probably come up with the fact that's going to be d, but specifically it is lowercase d, because capital D actually stands for something different. And so if I write lowercase d, you write lowercase d. Now, of course, if you're planning a trip, the time and the distance are quantities you want to know. The distance is pretty much invariant. You follow the steps along the way, you're going to travel that distance, but the time will depend on something else. What will the time depend on? Well, it's going to depend on how fast you're going, right? And so we'll call that speed, which we'll define as how fast something moves. But again, we're going to get a little more detailed. It's how fast something moves, irrespective of direction. So as long as the object is in motion, we quantify that as speed. It doesn't matter which way it's moving. Now we'll need a single letter symbol to use for speed as well. So we have t for time, d for distance, and so you're probably going to guess s. But it's not. No, we're going to use v. That's right. Now, some of you may already know why we can use lowercase v for speed, and if you do, that's fantastic. We're not going to get into it right now, but we are going to use lowercase v, and it does have to be lowercase because capital V does stand for something different. Now, know that my uppercase and lowercase v look an awful lot alike, especially if I don't have lined paper, it might be a little confusing. So I always like to write it as a lowercase script v. So I suggest you do it something similar. By the same token, I write my lowercase t with like a little bit of a hook on the end, just like this italicized t is drawn there, just because if this t is next to a plus sign in an equation, you don't want to confuse the two. So whatever you can do to make sure you know exactly what you're talking about. Okay, now there's different types of speed we could be measuring. The one we're really going to be focusing on right now is called average speed, where average speed is determined over an elapsed time. So it's going to take into account the entire event. Now this is a little bit weird. As soon as I define average speed, I'm going to tell you it's actually hardly ever the answer in a problem. Yes, certainly sometimes you can be calculating average speed, and the problem tells you to, you will, but usually we calculate average speed to get to something else. Average speed is different from instantaneous speed. Instantaneous speed occurs for just a moment in time. Maybe the speed right at the very beginning of the problem, or speed right at the very end of the problem, or speed at some moment during the middle of the problem, as opposed to average speed, which takes into account the entire problem, the entire event. So how do we differentiate? Well, in terms of symbols, instantaneous speed is just going to be a lowercase v, and then usually we have a little subscript there to indicate if it's at the beginning of the problem, or end of the problem, or somewhere in the middle of the problem. But for average speed, we draw it as a lowercase v with a horizontal line above it, which we call a bar. Now, in case you're having trouble seeing that, I'll draw it a little bit larger over here. So it's the lowercase script v with this horizontal line directly above it, which we say is a bar, and we actually say this out loud as v bar. So I want you to repeat after me and actually do this, right? So say v bar. Again, repeat after me. Say v bar. I hope you're doing it. I can't tell if you're doing it, but I hope you're doing it. Now I want you to do it because once you say v bar and people hear you saying v bar, they say, oh, this is a physics student, because only physics students say things like v bar. Now, you may have actually seen this bar before, maybe in your math class. If you ever see a horizontal line above a quantity, that may indicate it is the mean of a set of numbers. And of course, what does mean mean in math? It means average, right? So this literally says average speed, the mean of the speed. So this is v bar, which stands for average speed, where again, instantaneous speed would just be a v without the bar, and then usually a subscript there telling you where in the problem, or when in the problem you're finding that speed. Okay, so it is time for our first physics equation. We're going to put these symbols together to calculate average speed. Now, speed is something you've probably seen before in previous years in science. You've probably called it rate, although rate is too generic. We'll talk more about that later. But you probably already know an equation for rate, but we're now going to call it v bar, or average speed. And if you were just to write it down, you'd probably tell me it's distance over time. We want to use the symbols, right? So distance is lowercase d, and time is lowercase d, so we write it as d over t. Although that's not exactly correct. Specifically now in physics, when we talk about it as v bar being the average speed, we have to determine it over the entire problem. So it's going to be the total distance over the total time. This is now going to be our physics equation for average speed. V bar equals d total over t total, where we define those symbols over here. D total is the total distance covered, taking into account all the steps along the way. And t total is the total time it takes to travel that total distance. So this version of the equation is used when there are multiple steps in the problem. You want to calculate the total distance covered and all the time it took to do that, so we write that as d total over t total. If instead you're doing a problem and there's just one thing happening, one distance covered, and then a time for that, you don't have to write the subscripts total on both the d and the t, but this is the most generic version of this equation. So from this equation we can now determine the units for speed, because you might have noticed I left a blank space here. I hope you did too, because we've been doing the units. So let's just figure this out, right? Distance here we know is in meters, and time is in seconds. And so the standard units for speed are going to be meters per second. Just literally write the units one over the other, distance over time, meters per second. We want to write this here as the slash. We certainly could write as a fraction, meters on top, seconds on the bottom, but this is usually the way you write it when writing out quantities. And again, we're using these square brackets around it to denote that this is a pure unit. All right, last thing you want to do is just box in our equation. This is our first new physics equation. You want to highlight it in your notes. I like to box it here in red. And so here's our first physics equation. V bar equals d total over t total.